expansion, or it is also called expansion against vacuum. So first of all, there is any gas and there is a vacuum. So when the gas expands, volume increases definitely, because a gas occupies the volume of the whole container. So volume increases, mass remains constant. So if this was ideal gas, we can, if even if it was not an ideal gas or real gas, still pressure would decrease, that I'm certain. But if it was ideal gas, then I can say that if volume is doubled, then pressure will be halved. Why? What happened to the temperature PV is equal to MRT? Q is equal to 0 from the system because this is insulated. For expansion against vacuum, we take the system as insulation. So let us assume this is a system. Okay, this full as system. Work done by gas, work to displace atmosphere, plus work to lift piston as we normally do. No, there is no atmosphere, so work to displace atmosphere 0. The piston is removed, so there is nothing to, and expansion against what? Even if this was a vertical this expansion, still the work to lift the piston was 0. So work done by gas is equal to 0. As gas expands, it may release heat, or even if there isn't, as gas expands, it may release heat, but insulation, or even if there is no insulation, ये process इतनी fast होती है कि heat को कभी बाहर जाने का मौका नहीं मिलता. So Q is equal to 0. From here we can say W is equal to 0. That means delta U is equal to 0. If it was ideal gas, T1 is equal to T2. From P2 becomes half. But for real gas, T1 can be or cannot be decreased. This is irreversible adiabatic process because Q भी नहीं जा रहा है. और no, I cannot say is adiabatic. First of all, it is irreversible. As Q is equal to 0, W is equal to 0, delta U is equal to 0. It is first of all not an isothermal because it is irreversible. And for ideal gas this happens. Deductions: delta is equal to 0, Q is equal to 0, W is equal to delta H is equal to 0 only for ideal gas. Because why delta is equal to 0 is only for ideal gas? Yeah, this is valid for any fluid, any gas, anything, real, non-real, because this came from Q is equal to W plus delta U. But delta H is equal to, we came from MCP dt. MCP dt is only valid for ideal gas. From here we get for real gas T1 is equal to T2. So if we get delta H equals 0 only for ideal gas. For real gas it may or may not be 0, delta H. And what about the entropy? पहली बात, for any process to happen, delta H universe should be greater or equal to 0. E is equal to 0 is in the case of reversible, but expansion is not reversible, free expansion. That's why delta S universe is greater than 0. And delta surrounding is equal to 0 because there is no heat transfer to the surrounding. There is no heat transfer to the surrounding. So delta universe is equal to delta system. So delta system is greater than 0, not equal to, greater than 0. So entropy of the system increases, just plainly increases, not change. It changes and it increases.